Hello student, my name is Ritesh Yadav. I am assistant professor in Department of Electrical and Electronics Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. So today we will see mesh analysis for the network. So first we will see difference between mesh and loop. Then we will see mesh analysis. Then we will see numerical problems based on the mesh analysis. So first, see what is the difference between mesh and loop. So a loop is any closed path through a circuit where no node more than once is in count. So here you can see this is a loop. Okay, this is a loop, this is a loop, and this is a loop. So these are the loops. Then what is mesh? Mesh is defined as a loop which does not contain any other loop. So here you can see this loop, this one, this loop. So this loop is a mesh because this loop does not contain any other sub loop, or you can see here there is no other loop inside this loop. So this loop is a mesh. Similarly, this loop is a mesh and this loop is a mesh, but this bigger one, this one, this one is not a mesh because this outer loop, you can see this outer loop contains 3 loops. That's why this is not a mesh. So in this given network there are 3 meshes. So a mesh is a loop, but a loop may or may not be a mesh. So let's see the procedure for the mesh analysis. First you have to identify the total number of meshes, then assign the mesh current. Then third point is write the Kvl equation for each mesh, then solve the Kvl equation to find the mesh current. So there are some important point. Mesh analysis is applicable only for the planar network. And the direction of current. So this direction of current may be clockwise and anti-clockwise, but always take clockwise direction. Okay. You can take clockwise or anti-clockwise, but it will be easy if you will take the direction of current clockwise. Then third point is the number of equations required to solve any network using mesh analysis, that is b minus n minus 1, this one. So this b is the number of branch and n is the number of node in the given network. Then next point is super mesh. So this is the point number 4, super mesh. What is super mesh? When a current source is present between 2 meshes, so you can remove that branch having the current source, then the remaining loop is known as super mesh. So here you can see this circuit. In this circuit, how many meshes are there? This mesh 1. So in this mesh, this is the mesh current I1 suppose, and this is the another mesh. Suppose in this mesh, this is I2 mesh current. but you can see here there is a current source between mesh 1 and mesh 2. So in this mesh you cannot apply the KVL because the voltage drop across this current source is not known. So you cannot apply the KVL in this loop. Similarly, you cannot apply the KVL in this mesh, or you can say loop. Okay. So in that case you can remove this current source. So here you can see, after removing this current source, this is the remaining loop. So this will be a super mesh. So let's see example number 1. Find the current in 10 ohm resistance using mesh analysis. So this is the circuit. So first you have to identify the number of meshes. So here you can see this is the mesh number 1. So assign mesh current. Suppose this is I1 and this is the mesh number 2 and current is I2. Now write the KVL equation for each mesh. So first you have to write the KVL equation for this mesh number 1. So write KVL equation for mesh 1. So here you can see this I1 current is flowing through this resistance. So the positive sign will be here and negative sign will be here. Similarly, this positive sign will be here, negative sign will be here. And this I2 current is flowing through this 10 ohm resistance. So positive sign will be here, negative sign will be here, because the current is entering at this terminal. And this positive sign will be here, sorry. So this is I2 current. So this I2 current entering at this terminal. So that's why the positive sign is here and negative sign is here. Now you can apply the KVL. So just write the KVL for mesh 1. So 10, because here you are going from minus to plus. So this plus 10, then plus to minus. So there will be a voltage drop across the resistance. So minus I into R. So what is the value of I? That is I1 into 5. So you can write 5 into I1. Similarly, you can write minus here because you are going from plus to minus. So minus sign will be here. Then this I1 current minus I2. So here will be minus I1 minus I2 into 5, that is equal to 0. Okay. So 10 minus 5 I1 minus 5 I1 plus 5 I2, that is equal to 0. So you can write 10 minus 10 I1 plus 5 I2, that is equal to 0. So you can write 10 I1 minus 5 I2, that is equal to 10. So this is equation number 1, suppose. Okay. Now apply the KVL in this loop. So you will get write KVL in mesh 2. So minus, you are going from in this direction, I am applying the KVL. So plus to minus, so minus, then write I2 minus I1, because through this resistance, this current I1 and I2 both are flowing. So I2 minus I1, into 5, then write minus, so through this resistance 10 ohm I2 current is flowing, so it will be I2 into 10, that is equal to 0. So from this equation you can write, this is equation number 2, suppose, sorry, first rearrange this equation. So here you can write minus 5I2 plus 5I1 minus 10I2, that is equal to 0. Okay, so you can write 5I1 minus 15I2, that is equal to 0. Now suppose this is equation number 2. Okay. So you have this equation and this equation. So you have to find out this current I2 through 10 ohm resistance. So you just solve this equation number 1 and equation number 2. So you can write here (10I1) minus 5I2, that is equal to 10. Okay, you just multiply this equation number 2, or you multiply this equation number 1 with, actually here you have to find out this current I2. So it's better to multiply this equation number 2 with 2. So after multiplying this equation with 2, you will get so here it will be 10 and this will be 30. So it will be 10. After multiplying, this will be 10 and this will be 30. Just multiply this equation. So here you can see minus plus minus, so this will get cancel out. So here you will get 25 I2 minus, that is equal to minus 10. So this will cancel out. So this will be 2 and this will be 5. So from here you will get I2. So this I2 is equal to 2 by 5 ampere. 2 by 5. So here you can see I is the current through 10 ohm resistance. So this way you can find out by using this mesh analysis. So let's say this example number 2. So in this example you have to find out the current value I using mesh analysis. Okay, so first you have to identify the number of mesh, then you have to assign the mesh current. So first you just see, this is mesh number 1, assign mesh current, that is I1, and this is mesh number 2, so current will be I2. Then this is mesh number 3, assign current I3. Now write the KVL equation for each mesh. First write the KVL equation for mesh number 1. For mesh 1. So this is the mesh number 1. So this I1 current is flowing through this 2 ohm resistance. So positive sign will be here and negative sign will be here, because this current I1 is entering at this point, then leaving this resistance at this point. Okay, similarly you can put the plus minus here and plus minus here. So I2 current is flowing through this resistance, so the I2 current is entering at this point. So the positive sign will be here and then negative sign. Similarly plus minus plus minus. Then for the I3 current, so positive sign will be here, negative sign will be here, then positive and negative. Okay. Then write the KVL equation. So first write the KVL equation for mesh number 1. So plus 2, then minus 2 into I1, then minus 1 I1 minus I3. So this is the voltage drop across this resistance. Then you can write 1 into I1 minus I2, that is equal to 0. So this is voltage drop across this resistance. Now rearrange this equation. So 2 minus 2I1 minus I1 plus I3 minus I1 plus I2, that is equal to 0. So 2I1 minus I1 minus I1. So it will be minus 4 I1 then plus I2 plus I3, that is equal to minus 2. Okay. So you can write 4 I1 minus I2 minus I3, that is equal to 2. So this is equation number 1. Okay. Now just see here, this I3 current is nothing but 2 ampere. Because in this loop you cannot apply the KVL because the voltage drop across 2 ohm resistance is not known. But this I3 current is 2 ampere. So you can write I3. Suppose this is equation number 2. Now you can put this value here. So just I3 value you can put here. So you will get 4 I1 minus I2 minus 2, that is equal to 2. Okay. So from here you will get 4 I1 minus I2, that is equal to 4. Suppose this is equation number 3rd. Okay. Now write the KVL for this mesh. Plus minus, and here the current is I1 and this is the I3 current. Okay, so plus minus for I3 current, and this plus minus for I2 current, this plus minus for the I2 current, and here will be plus minus. So write the KVL. For mesh 2. So minus 1 into I2 minus I1, then minus 1 I2 minus I3. This 1 into I2 minus I3 is the voltage drop across this resistance. Then 1 into I2, that is equal to 0. So this 1 into I2 is the voltage drop across this resistance. Now rearrange this equation. So minus I2 plus I1 minus I2 plus I3 minus I2, that is equal to 0. So you can write I1 minus 3 I2 plus I3, that is equal to 0. Okay. I1 1 2 3 minus I2 plus I3, that is equal to 0. Now you can put I3 is equal to 2. So I1 minus 3 I2 plus 2, that is equal to 0. So I1 minus 3 I2, that is equal to minus 2. Suppose this is equation number 4. Now solve equation number 3 and 4. So you have equation number 3, 4I1 minus I2, that is equal to 4. So this is equation number 3. Okay. Now multiply equation number 4 with 4. So just multiply this equation number 4 with 4. So you will get 4I1 minus 12I2, that is equal to minus 8. Okay. Now you can write equation number 3 here. 4I1 minus I2 that is equal to 4. Now subtract equation number 3 from 4. Minus plus minus. So this will get cancelled out. This will be minus 11 I2 that is equal to minus 12. So this will get cancelled out. So I2 is nothing but 12 by 11. So this is the current through 1 ohm resistance. So this way you can find out the current using mesh analysis. So this is the another example. Determine the 3 mesh current in the given network. So in this network you can see this one current source is present between 2 meshes, mesh number 1 and mesh number 2. So there will be a super mesh. So in this case, in this network, first draw the super mesh. So this is the super mesh. Okay. So write the Kvl equation for the super mesh, because you cannot write the Kvl equation for this mesh number 1 and mesh number 2 because the voltage drop across this current source is not known. Okay. In that case, you can remove this current source branch, then the remaining loop will be super mesh. So just write the Kvl for the super mesh. Write KVL for super mesh. Okay. So first write the equation number 1. So here you can say this is the direction of I1 current and this is the direction of I3 current. So you can write I1 minus I3 that is equal to 7. Suppose this is equation number 1. Okay. This current relation will give equation number 1. Now write the KVL for the super mesh. So 7 plus 7, then voltage drop across this resistance. So this is plus, this is minus, suppose. So minus 1, this will be I1 minus I2, because through this resistance, this current I1 and current I2 both are flowing. Then write the voltage drop across this resistance. So plus 2 minus. So minus 3, you can write I3 minus I2, because the I3 current is flowing in this direction and I2 in this direction. Then write the voltage drop across this resistance. So minus 1 into I3 that is equal to 0. Now rearrange this equation. 7 minus I1 plus I2 minus 3I3 plus 3I2 minus I3 that is equal to 0. Okay. Now 7 minus I1 plus I2 plus 3I2, this will be 4 I2, then minus 4 I3 that is equal to 0. So you can write I1 minus 4 I2 minus 4 I3 that is equal to 7. So this is equation number 2. Okay. Now you have equation number 1. You have equation number 2. Now write the KVL for mesh number 2. Write KVL for mesh number 2. So in this direction you can write the KVL plus minus plus minus plus minus. So minus 1 into I2 minus I1, then minus voltage drop across 2 ohm resistance, that is I2, then voltage drop across 3 ohm resistance. So minus 3 I2 minus I3, that is equal to 0. So you can write minus I2 plus I1 minus 2I2 minus 3I2 minus plus 3I3, that is equal to 0. So I1 minus 1 2 1 3 3 to 5. This is 5I2, then plus 3I3, that is equal to 0. So this is equation number 3. So I1 1 3 2 5 1 6, this will be 6. I2 and 3I3. Now you have equation number 1, equation number 2 and equation number 3. So solve equation number 1, 2 and 3. So after solving the equation number 1, 2 and 3, you will get I1, that is equal to 9 ampere, I2 is equal to 2.5 ampere and I3 is equal to 2 ampere. Okay. So these 3 equations you can solve by using calculator, or you can solve by using matrix approach. So the matrix approach I will discuss in the next lecture. Now see this example, next example. So in this network, this dependent voltage source is present. Okay, the process will be same. First you have to identify the number of mesh. So this is the mesh number 1. What is the current? I1. This, and this is the mesh number 2, and current is I2. Then write the KVL equation for mesh number 1 and mesh number 2. So first write the KVL for mesh number 1. Write KVL for mesh number 1. So this is mesh number 1 and this is mesh number 2. Okay. So actually the direction of current is clockwise. So write the KVL in clockwise direction. So just minus 3, then minus 4, because the plus sign will be here and minus sign will be here, plus minus, and for this current plus minus will be here and the plus minus will be here. So just write the voltage drop across this 4 ohm resistance. So this 4 I1 minus I2, then minus 2 into I1, that is equal to 0. So minus 3 minus 4 I1 plus 4 I2 minus 2 I1, that is equal to 0. So you can write minus 6 I1 plus 4 I2, that is equal to minus 3. So you can write 6 I1 minus 4 I2, that is equal to 3. Suppose this is equation number 1. Okay. Now write the KVL for mesh 2. Okay, so plus 5 plus 4 I1, then minus 4 I2 minus I1 minus 4 I2, that is equal to 0. So this 4 I2 is the voltage drop across this 4 ohm resistance, and this one is the voltage drop across this 4 ohm resistance. Now rearrange this equation. So 5 plus 4I1 minus 4I2 minus plus 4I1 minus 4I2, that is equal to 0. So it will be 8I1 minus 8I2, that is equal to minus 5. Suppose this is equation number 2. Now solve the equation number 1 and equation number 2. So what is equation number 1? For right here, 6I1 minus 4I2, 6I1 minus 4I2, that is equal to 3. Then you have 8I1 minus 8I2, that is equal to minus 5. Now solve this equation. So just multiply this equation with 2 and subtract this equation from this equation. So it will be 12I1, sorry, this will be minus. Minus 8I2, that is equal to 6. So this will be minus, this will be plus, this will be minus. Yeah, so minus 4I1, this will get cancelled out, that is equal to I think this one is minus 3I1 minus 4. This will be plus, this will be minus. Repeat. So let's see this example. In this example, you can see here the dependent voltage source is present. So again, you can find out this loop mesh current I1 and I2 by using mesh analysis. So first, find the number of loop. So this is the mesh 1 and this is mesh 2. Suppose the current I2 is through mesh 2 and this I1 is the current through mesh 1. Okay. Now write the Kvl equation. Write the Kvl equation for mesh 1. So you can write minus 3 minus 4 I1 minus I2 minus 2 I1, that is equal to 0. So this 4 I1 minus I2 is the voltage drop across this 4 ohm resistance, and this 2 into I1 is the voltage drop across this 2 ohm resistance. Okay, and the sign will be like this, plus minus and plus minus. And for this I2 current, plus minus will be here and plus minus will be here. Now rearrange this equation. So minus 3 minus 4 I1 plus 4 I2 minus 2 I1, that is equal to 0. So you can write minus 3 minus 6 I1 plus 4 I2, that is equal to 0. So minus 6 I1 plus 4 I2, that is equal to 3. So you can write plus 6 I1 minus 4 I2, that is equal to minus 3. Suppose this is equation number 1. Now write the KVL for mesh 2. KVL for mesh 2. So 5 plus 5, then plus 4 I1 minus, then voltage drop across this resistance, so 4 I2 minus I1, then voltage drop across this resistance minus 4 I2, that is equal to 0. So you can write 5 plus 4 I1 minus 4 I2 plus 4 I1 minus 4 I2, that is equal to 0. So it will be 8 I1 minus 8 I2, that is equal to minus 5. This is equation number 2. Now solve the equation number 1 and equation number 2. Solve equation number 1 and equation number 2. So you have 6 I1 minus 4 I2, that is equal to minus 3. Then you have 8 I1 minus 8 I2, that is equal to minus 5. Now multiply this equation number with 2. Then subtract this equation from this equation. So it will be 12 I1 minus 8 I2, that is equal to minus 6. So minus plus minus, so this will get cancelled out. This will be minus 4 I1, that is equal to, sorry, this will be plus. So this will be plus 1. So I1 will be 1 by minus 1 by 4. So you can write I1, that is equal to 0.25 ampere, or I1 is equal to 250 milliampere. Now put I1 value in equation number, this equation. So, or you can put in this equation, so 8 into minus 1 by 4 minus 8 I2, that is equal to minus 5. So this will be 2. So from here you can write minus 8 I2, that is equal to minus 3. So I2 is equal to 3 by 8 ampere. So this value will be equal to 0.375 ampere, or 375 milliampere. So I1 value is minus, so minus sign will be here, minus 250 milliampere, and I2 value will be 375 milliampere. So this way you can solve any network by using mesh analysis. So this is all about for today's lecture. Thank you.